Okay, I will revise again what we discussed yesterday. Okay, so photoelectric effect. What is the definition of photoelectric effect? Means when a light of suitable frequency incident on the surface of a metal, there is an emission or liberation of electrons from the surface of a metal is called as photoelectric effect. Photoelectric effect. Okay, so that means if you will take any metal plate, in that metal plate suitable frequency of light is instant on that metal plate. What happen means electrons will be emitted or electrons are ejected from the metal plate. So that phenomena is called as photoelectric effect. Okay, so this phenomena first discovered by Hedge and experimentally verified by Hall watchers, Leonard, J.J. Thomson, R.A. Millikan, and others. Okay, yeah, Einstein. So, what is the role of Einstein here? Means he explained by using equation. By using equation, he explained the photoelectric effect. Okay, so that is the introduction of photoelectric effect and definition of photoelectric effect. Now coming to the what is the working phenomena. What is the working phenomena here means, see, so this is the, so light is instanting, light, that means light is so instant on the metal plate here. So that means light is here, we will consider as a like if what is that particle, like a particle. So that means what is the use of photoelectric effect means, by using photoelectric effect we can explain that light having particle nature, light having particle nature. So that means by using wave nature we cannot explain the photoelectric effect. Okay, so that's why if light, that means photoelectric effect is occurring means, so light should have particle nature, then only photoelectric effect will be occur. Okay, see here, so that means if you increase the intensity of light, so intensity of light means intensity is nothing but number of photons passing through the unit area, number of photons passing through the unit area. If you increase the intensity, what happen, current also increases. If you increase the intensity, that means if you increase the intensity means number of photons will be increased. If number of photons are increased means what happen, so number of emitting electrons also increased. If electrons are increasing means, so current passing through the circuit also increases. Okay, so that means if here current passing through the circuit is depends on the intensity of the photons, okay. Yeah. So for the experiment, so what we will take means, here we will take the two metallic plates. So one metallic plate is act as a cathode, another metallic plate is act as a anode. These two metallic plates are fixed inside the quartz tube, okay, and those are separated by a certain distance, here. Okay, so and this quartz tube is vacuumed, fully vacuumed. Okay, so now if any light is instant on a, so cathode is nothing but that metallic plate is connected to the negative terminal. So this is cathode is let us take this cathode is plate A and anode is plate B. Okay, so cathode is nothing but, so this is the negative plate. Negative plate is nothing but this plate is connected to the negative terminal of the battery. And this plate is connected to the positive terminal of the battery. When light rays is instant on the metallic plate, what happen means electrons will be ejected. Those ejected electrons are collected by anode, and electrons are passing through the circuit. If electrons are passing through the circuit means current will be produces. So this is the circuit diagram of photoelectric effect. Okay, so and explanation. Okay, this is the whatever we discussed previously, so that is the total here. Okay, now yeah, so Einstein explanation for photoelectric effect. Okay, according to the Einstein explanation, In photoelectric effect, one photon is completely absorbed by one electron, which thereby gains quantum energy and may be emitted from the metal. Okay, so that means according to the Einstein explanation, what when light is instant, on a metallic plate, so that means light having so photons, each that means each packet of light will act as a one photon. That means it's act like a particle. So that photon energy is absorbed by the one photon energy is absorbed by the one electron. Okay, so that means that photon energy does not supply to the, so only another electron it's absorbed by the, that means that photon energy is absorbed by the only one electron. Okay, and so if the energy is sufficient energy, if the energy is photon energy is sufficient energy, so what happened, then it will emit from the metal plate, okay, according to the Einstein. Here that photon energy is used in two parts, used as a two parts. Okay, what are those two parts? Means some part, so that means photon energy is here, some part of energy is absorbed by the electron, some part of energy is absorbed by the electron, and it will be that will be useful to eject the electron from metal surface, so that energy we will call it as, so w naught. Here see once again, part of its energy is used to free the electron from the atom, and away from the metal surface, this energy is known as photoelectric work function. So this is denoted by w naught. Okay, so that means photon energy is, so here divided into two parts. One part is used as a work function. Okay, what is the definition of work function? Means the minimum energy required to eject the electron from the metal surface. The minimum energy required to eject the electron from metal surface is called as work function. That means the photon energy is divided into two parts. One part is used as a work function. So what is the another part? Another part means the other part is used to give the kinetic energy of the electron, to the electron. Okay, so that means here photon energy is divided into two parts. One part is used as a work function, another part is used as a, so kinetic energy of the electron. Okay, so now that means what is the work function? That means what is the energy of the photon? H nu. That means it depends on the frequency. Photon energy depends on the frequency. Okay, so H is Planck's constant here. Nu is the frequency of the photon. Here what is the photon energy? Means each photon, suppose I am taking only one photon here. One photon is instant on the metal surface. So that energy is equal to h nu. That energy h nu is divided into two parts. So one is W naught, another one is kinetic energy. So this W naught is the work function. So work function is nothing but the minimum energy required to eject the electrons from the metal surface. Okay, so that means if you give less energy than the work function means that electron does not eject from the metal surface. Okay, so that means if you give the if photon energy is more than the W naught, if photon energy is more than or equal, so greater than or equal, so then only electron will be eject from the metal surface. If photon energy is less than or equal to, h nu is less than or equal to W naught, means electron does not eject from the metal surface. Okay, so that means here photon energy is divided into two parts. Okay, one part is act as a work function, another part of the energy supplies to the electron. That means because of electrons, so due to that energy, what happen? Electron will gain the some velocity. Electron will gain the some velocity. Okay, so that means it will become a kinetic energy. It will become a kinetic energy. So this equation we will call it as Einstein photoelectric equation. This equation we will call it as Einstein photoelectric equation. Okay, now coming to the here. So that photoelectric is photoelectric effect is depends on the some following factors. So what is those following factors means? So first one is the stopping potential, and second one is the intensity of incident radiation, third one is the frequency of incident radiation, and fourth one is the effect of photometal. Effect of photometal. Okay, so now first we will discuss about the stopping potential. Okay, stopping potential. Yeah, see here, stopping potential uh, first initially. So initially what we are doing here, so we are supplying some potential to the metallic plates, some potential to the metallic plates. So for positive plate, that means for cathode, we are connecting to the negative terminal. That means this is the negative plate, act as a cathode, and anode we are giving to the positive terminal, that act as a anode, that act as a anode. So this is positive plate. This is the positive plate. Act as a positive plate here. Okay. Now, so and for finding the stopping potential here, what we are doing means, so we are keeping intensity of light is constant. Intensity of light is constant, as well as frequency of the light is constant. For finding the stopping potential, here we have to make two constant values. What are those means? So metal plate also constant. Metal plate also we are not changing. So because so photoelectric is depends on the four parameters here. Four parameters. If you want to find any one parameter, suppose if you want to find the stopping potential here, if I want to find the stopping potential here, so that's why remaining three parameters I have to keep constant. Okay, so that's why here, so for finding the stopping potential, so what I am taking constant means intensity of the light is I am taking constant, and frequency of the light also taking constant. Frequency of the light also taking constant, and so metal plate also constant. So we are not changing any. So metal plate, I am taking only one type of metal plate here. Okay, so here we are keeping three constant values. Now I will find out the, so what is the stopping potential. Yeah, initially what we are doing here, so negative terminal is connected to the this A plate, and positive terminal is connected to the B plate. Positive terminal is connected to the B plate. So now what happened here? So if initially, yeah, so here when light is incident on here, electrons will be ejected. Electrons will be ejected. Those electrons are reaches to the this plate from cathode to anode, from cathode to anode. So what happened here? Current is passing through the circuit. Now what I am doing means, so I am increasing the applied potential. That means here we are applying negative terminal, positive terminal. That means there is a potential difference between these two plates. Potential difference between these two plates. So if increasing the voltage here, what happened? Potential difference also increases. Potential difference also increases. Okay. So if you increase the potential difference, what happened means, see here, if you increase the potential difference, so that current is photocurrent is increases. Photocurrent is increases up to particular value. Photocurrent is increases up to particular value. After that, if you increase the voltage also, photocurrent will become constant. Photocurrent will become constant. So that means up to particular value of the potential, what happened? So current is photocurrent is increases. Photocurrent is increases. If you increase the further voltage also, what happened? So current does not increase. It will become saturated. What is the reason? Can anyone explain? If you increase the voltage also, what happened? Current is here saturated. Current will become constant. So what is the reason means here? So emitted electrons. So that means current is depends on the here emitted electrons only, na? Okay, how electrons are emitting means when photons are incident on the metal plate, electrons will be emitted. Okay, so how many number of electrons are emitted means it depends on the intensity. It depends on the intensity of the light. So we are taking intensity is constant. Suppose here intensity means some 10 photons are passing through the instant on that metal plate. 10 photons are instant on the metal plate means only 10 electrons are ejected. 10 electrons are ejected here. Okay. So initially, if you apply the less potential, means what happened? Some electrons are moved this side, some electrons are moved this side, some electrons are moved this side. If you increase the potential difference, means, so this is the positive plate. Positive plate means this positive plate try to attract the all electrons. Okay, try to attract the all electrons at a particular potential. What happened? All electrons reaches to the this anode. All electrons reaches to the this anode. So that's why what happened? So if you increase the further potential, difference also, so number of electrons does not increase. That's why current also does not increase. Okay, at a particular potential, what happened? All photons are reaches to the all electrons are reaches to the this anode. All electrons are reaches to the anode. So that's why what happened? Current will become saturated. If you increase the voltage also, there is no extra electrons. So if electrons will be increased, then only current is increases now. Okay, so that's why what happened here? Current will become saturated if you increase the voltage also. Okay, so now, so this is the what is that? If you increase the voltage, what happened? Current will be like that. Now, so if you will take, so if you remove the potential here, that means if you remove the battery means, so here potential difference between the anode and cathode is zero. Potential difference between the anode and cathode is zero. If potential difference zero also, what happened? Some current is passing through this circuit. What is the reason? Means here, see here, electrons are ejecting from the metal plate. Those electrons have some kinetic energy because some photon energies. So that means here photon have certain energy. That energy supplies to the electron. That energy is absorbed by the electron. Some energy is used as a work function. Remaining energy is converted into what is the kinetic energy. So that's why if electron have kinetic energy means it has some speed. So that's why because of that kinetic energy, what happened? These electrons will reaches to the this plate to this plate. That's why if you if potential difference between the plates will be zero also, there will be some current. See here. So I am making here potential difference zero. Potential difference V equal to 0. So if 0 also, what happened? There is some current will be flowing through this circuit. Okay. Yes. Okay, that is, so if make the potential difference 0 also, some current is passing through the circuit. Okay, now what I am doing means, now I will previously what I will do, so I will apply the positive terminal here, negative terminal here. What I will do means, now I will apply the negative terminal here and positive terminal here. Okay, that means I am applying voltage in opposite direction. Okay, yeah, if we increase the, that means negative terminal is connected here. So previously positive terminal are connected. So but what I am doing means, now I am doing the reverse connection. Means negative terminal of the battery is connected here, positive terminal of the battery is connected here. That means now I am applying the voltage in opposite direction. Okay, in opposite direction, if you increase the voltage, what happens? Suppose initially I am applying here minus 1 volt. So here minus, I am connecting the minus 1 volt. Minus 1 volt means, so due to that means there is some potential difference between these two. Okay, that is the negative opposite potential. So for minus 1 volt, there is some little amount of current is passing through the circuit also. So little amount of current pass here. Ammeter is connected. Ammeter measures the current, how much current is passing. Okay, so there is a little amount of current passing in opposite potential also. If you increase the opposite potential here, minus 2 volts also, there is some current. Suppose if you apply the minus 3 volts, so for minus 3 volts, there is no current is passing through the circuit. Okay, so that means that is called as stopping potential. at which opposite potential, the current passing through the circuit is zero. At which opposite potential the current passing through the circuit is zero. That potential we will call it as stopping potential. Okay, so here, so did you observe the observe here? So that means if you apply the negative potential also, there is a little amount of current up to particular voltage. What is the reason means? Here we are applying, so positive terminal means we are applying opposite terminal, means we are applying positive terminal, here applying negative terminal. Okay, so now when electrons are photons are incident, means electron will be ejected. So some energy is used as a work function, and some energy is used as a kinetic energy. So electron have some kinetic energy. Okay, the kinetic energy is greater than the applied potential. That kinetic energy is greater than the applied potential. What happened? That electron reaches to the this plate to this plate. This 1 minute. So this electron kinetic energy is greater than the applied potential difference. What happened? Electron will reaches to the this plate to this plate. Okay, so whenever this potential difference, applied potential difference is equal to the kinetic energy, this applied potential difference equal to the kinetic energy of the electron, what happened? Electron doesn't reaches to the this plate because electron have negative terminal, so this is positive terminal. Okay, that's why what happened? So if it will be kinetic energy is greater, means it oppose, that means it's overcome the potential difference and it will reaches, but it kinetic energy is equal or less, means what happened? Electron doesn't reaches to the this metal plate, this anode or plate B. So that's why there is no current passing through the circuit. Here. Okay, so this is about the stopping potential, and that means what is the definition of stopping potential?
The potential at which the potential at which we doesn't find any current passing through the circuit.
Yes, that is the stopping potential. Okay.
Stopping potential.
Yes. Okay. Very good. Okay. Now this is about the stopping potential. Okay. Yeah. So this is the curve again. So voltage versus current. So that means here, so current, if you increase the voltage in this direction, means what happened? Current is increases up to particular value. After that, it will become saturated. Okay, if you apply the voltage in opposite direction, what happened? So up to particular value, so there is a little amount of current. Up to particular value, there is a little amount of photocurrent. So at a particular voltage, the current will become zero. So that is the opposite voltage. So at a particular value of the opposite voltage, so current will become zero. That voltage we will call it as stopping potential here. Okay, now the intensity. So first parameter is stopping potential, and second one is the intensity of incident radiation. Okay, same curve, previous curve only. So for current versus voltage here, so what we are doing means we are increasing the intensity. So if you increase the intensity, what I said, intensity of the photon. If you increase the intensity of the photon, intensity is nothing but number of photons passing through the unit area. So that means if you increase the intensity of the light, means what happened? More number of photons are incident on a metal plate. That's why what happened? More number of electrons are ejected. If number of electrons are increasing, means current is increases. Okay, so for less intensity, if you increase the intensity high, means what happened? Current also increases. See this curve. Okay, so that means if you increase the very high intensity, means the current also increases. See one more thing here, stopping potential. Stopping potential is does not depends on the intensity. See here. So stopping potential is constant for all intensity values. Okay, so intensity will, if you increase the intensity, what happen? Current is increases, but stopping potential does not change. Because if you increase the intensity, only number of electrons will be increases. Their kinetic energy does not increase. Their kinetic energy does not increase. Kinetic energy is only depends on the frequency. Kinetic energies only depends on the frequency. That means if you give the high frequency means, so work function is constant for metal. Work, if you will take one metal, so work function is constant. Work function is constant. So that means if you increase the intensity, what happen means, so that energy is divided into two parts. One part is work function, another part is kinetic energy. That means if you increase the intensity, work function is constant means what happen, kinetic energy is increases. Okay, so that means uh, if you increase the kinetic energy, then only stopping potential will be changes. If you increase the intensity here, kinetic energy does not change. Kinetic energy of the electron does not change. So that's why stopping potential also does not change. Okay, so that means stopping potential is does not depends on the intensity of the radiation. Intensity of the radiation. If you increase the intensity of radiation, what happen? Only current is increases. Only current is increases. Okay, now coming to the next point, the frequency of incident radiation. The frequency of incident radiation here. Okay, so now 1 minute. Okay, so the frequency of incident radiation here, consider the so already we discussed about the frequency. So if here stopping potential versus frequency, stopping potential versus frequency, if you increase the frequency, if you increase the frequency of the light, what happen? If you increase the frequency of the light, so what happen?
Increase in kinetic energy, sir.
Yeah, so number of electrons doesn't change. If you increase the frequency of light, so number of electrons doesn't change. Number of electrons will be depends only on the intensity. Okay, see, does not depends on the frequency. So if you increase the frequency, only kinetic energy of the electrons will be increases. If kinetic energy of the electrons will be increases means what happen? Stopping potential will be increases. If increasing the stopping frequency here, frequency I'm changing in x-axis, so stopping potential will be in y-axis. If you increase the frequency, what happen? Stopping potential is increases. Stopping potential is increases. Okay, so there is a minimum frequency is required to emit the electron. So that frequency we will call it as threshold frequency. So that means here minimum energy is required to emit the electrons. Okay, so that is called as work function. That is called as work function. Okay, so that means minimum energy is required means, so minimum frequency required energy is nothing but omega naught equal to h into nu naught. H into nu naught. Nu naught is the minimum energy required. Minimum frequency required to emit the electrons. Okay, so if frequency is less than the light frequency is less than the that nu naught, that means minimum frequency, what happened? Electron does not emit. Electron does not emit. So that frequency we will call it as threshold frequency. Threshold frequency. Okay, so here understood frequency here. So if you increase the frequency, what happen? Stopping potential is increases. What is the reason? Means if you increase the frequency, kinetic energy of the electron will be increases. So that's why stopping potential of the what is that that instrument will be increases. Stopping potential of the metal will be increases. Okay, yeah. Now, so one more thing here. So there is a minimum frequency is required. Minimum frequency is required to emit the electrons. So that minimum frequency we will call it as threshold frequency. Minimum frequency we will call it as threshold frequency. If frequency is greater than threshold frequency, so electrons will be emitted from the metal plate. If frequency is less than the threshold frequency, electron does not emit. Electrons does not emit. See here. Here photocurrent versus so potential here, potential, that means voltage versus current we are drawing, so with the different frequencies, so if you observe here, so stopping potential, this is the stopping potential. So if increasing the potential value here, if increasing the potential value, if increasing the frequency value here, so this is the less frequency, this is greater frequency, this is the very greater frequency. So if increasing the frequency, stopping potential is increases. Stopping potential is increases. Okay, but the saturation current, that saturation current is constant. Saturation current is constant. If you increase the frequency, what happen? So kinetic energy only increases, but number of electrons are does not increasing. So that's why saturation current is constant. Saturation current is constant. Observe here. So if you draw the graph between, so what is that? Voltage versus current, voltage versus photocurrent at different frequency values. At different frequency values, curves will be like this. Curves will be like this. What is the changing means here? So if increasing the frequency, stopping potential is increases. Stopping potential is increases, but saturation current is constant. Saturation current is constant because so if increasing frequency, number of electrons does not increase. Number of electrons does not increase. Okay, so that's why what happened here. So number of electrons are not increasing. So that's why saturation current does not increase. So its value will become constant. But in case of previous case, intensity, if you increase the intensity, yeah, if you increase the intensity, stopping potential is constant. But so if you increase the what happened? So intensity means what, that saturated current will be increases. Saturated current will be increases. Okay, yeah. Here, yeah, here nu naught means already we discussed, that is the, yeah, effect of photometal. Fourth point is here photometal. Photometal means it's a type of material. Which type of material we are using? Okay, which type of material means work function is if you will take one particular material. If you will take one particular material means if you change the that means if you increase the intensity or frequency, work function does not change. If you increase the frequency or potential or what is that intensity, work function does not change. So it's only depends on the type of material. That means work function is material property. Work function is material property. It's only depends on the type of material. Type of material here. Yeah, the following graph between the potential and instant frequency for a different photometals. It is clear from the graph that all the lines have the same slope, but their what's that interactions with the frequency axis are different. See here, yeah, I am taking here instead frequency on x-axis. So what is that? Here in y-axis, what we are taking here, frequency on x-axis, and potential difference, yeah, stopping potential on y-axis. Stopping potential on y-axis here, frequency on x-axis, stopping potential on y-axis. If increasing the frequency, what happened? Potential is stopping potential is increases like that. Okay, but it's only depends on the type of metal. Okay, for metal A, so work function will be constant. Work function will be constant. For metal B, work function will be constant. Okay, so its work function only depends on the type of metal. Type of metal. Thus we conclude that threshold frequency is function of photometal. That is, it depends on the nature of photometal. So threshold frequency, if you will take that threshold frequency means nu naught. Nu naught is constant for this metal. So here nu naught is so constant for this metal. So that means nu naught threshold frequency. So if you will take whatever the intensity, whatever the it will be that, so threshold frequency is constant. Threshold frequency is constant means work function is constant. So what is the relation between threshold frequency and work function? So W naught, work function is W naught. W naught equal to H into nu naught. H into nu naught. Nu naught is threshold frequency. So threshold frequency only depends on the type of metal. If you will take different metals means threshold frequency will be different. Threshold frequency will be different. Threshold frequency is different means work function is different. So work function is different for different metals. Threshold frequency or work function does not depends on the frequency of light, intensity of light, and so applied potential. Applied potential. Okay, this is about the what is that potential? Yeah, so potential. Now characteristics of the photoelectric effect. Yeah, the threshold frequency is different for different material. Okay, so threshold frequency is different for different material. Photoelectric current is directly proportional to the intensity of light. So what we discussed, and so these are the main points. So what is that means? Threshold frequency is different for different material. Yes. Who is that? Yeah. Now, photoelectric current is directly proportional to the intensity of light, and the kinetic energy of the photoelectron is directly proportional to the frequency of light. And stopping potential is independent of the intensity of the incident radiation. Okay, different metals have different work functions. Here some list is given. So if you will take sodium, that work function is 2.28 electron volts. So aluminum work function is 4.08 electron volts. Copper work function is 4.7 electron volts. That means different metals have different work function. That work function does not depend on any other parameters. Okay. Yeah. So this is about the photoelectric effect. Yes. So tomorrow we'll discuss about the Compton effect.